Thanks very much for sticking with us and staying on. It's been a long couple of days and a long day today. So we won't be looking to taking too much of your time, but at the same time, we don't want you to miss an opportunity to to review some of the work that we've done and the work that we are currently doing. Without further ado, we'll just carry on. So, in terms of us, the speakers, I'm Thomas Nachi. I work for Kia. I'm a design manager. My background is as an architect. I'm a chartered architect. I've worked in practice, and I've also worked for the United Nations. And I started work for Kia about 3 years ago. So my role as a design manager also takes into consideration looking after BIM implementation in Kia Central, which is one of the regions for Kia Group. So we've got 4 offices, and basically we've got a team that is looking after BIM. Ask Andrew to introduce himself.
Afternoon all. Thanks for attending. Andrew Givens from Topcon. Topcon are a global manufacturer of positioning equipment, GPS, total stations, mass data collection tools. I've been with Topcon about 12 years now, and I'm senior applications engineer looking after the geospatial products. So all of the products that I've mentioned, UAVs, laser scanners, mobile mapping, total stations, and BIM solutions, working in conjunction with Autodesk. You'd be pleased to hear I'm not here to push the sales pitch, just describe a couple of the workflows and the instruments that we used in particular on this project with Kias.
So in this session, what we are hoping to impart to yourselves and share with you is how we at Kia have managed to use a workflow to improve traditional site processes. I mean, as a contractor, it's one of the key things that we are looking to, making sure that we work with our site teams to improve what they do, integrating workflows between ourselves, the main contractor, and teams that are based in different locations within the UK, and just making sure that things work together and how BIM can be used to bring that together. And then on this this particular project, we're going to try and appraise the real benefits of real-life integration of laser scanning and on-site verification techniques on a construction site. I think it's one of the key things that coming across that we need, after constructing, we need to at least demonstrate to the client that what we have produced is what they have asked for, is what was designed. And then obviously the key benefits of working in a BIM environment is the collaborative working and making sure that we involve the supply chain and that we adopt technology on our construction sites. Looking at the project that we are, going to review mainly today. I mean, obviously we've gone through quite, we've got a lot of projects that that we have gone with. It is a university technical college based in South Gloucestershire, and basically it's a 3-story building that's going to be built as pretty much, I wouldn't say direct extension, but it's on a site that's already developed, and some of the works that that we do that we've already done within that site are integrated into this project. So just to give a context of this site and how the architects with studios, they produced at the very beginning of the concept stage when they had to during the bid process, they produced a 3D model. So we were already on track to making sure that we have a 3D. We're working in a 3D environment, in a BIM environment. It was part of the client requirements. So why BIM on this on this particular project? To start off with, Kia implemented or introduced a BIM policy in 2016 last year. Just to make sure that we all work, in BIM, and basically it is mandatory to, to use BIM on all projects until you've got a specific reason for not using BIM. So as such, it is made, sort of, quite clear throughout the, the group that, we have to, to use BIM, and on our, intranet, it is well, sort of, it is well advertised, or it is made clearly that we should use BIM. And that slide that starts with Mike here, there, it does sort of give a clear message that all jobs should be done in BIM, and it should be a collaborative process that should lead to customer satisfaction, and also that we as a group change the way, the culture that that we work, so that we embrace BIM. And like I mentioned earlier on, we talk about the main contractor and the supply chain working together to bring benefits to everyone involved on the job. So one of the key things that you would look to, or that you would expect on a BIM project would be how do you manage the information, how do you gather together the data that's that's produced by various teams from different locations working together towards a common goal. So starting off with the the main consultants on the job. So we've got the the architects here with studios. And then we've got the MEP consultant, TBA, and the structure and civils job. Basically in a typical BIM job, we would expect, sort of at the end, that we'll have a model from the architect, we have a model from the MEP, got a model from the structural engineer. One key factor here, or one point to to take into consideration or to take note of, is that these consultants were using different authoring tools. So we've got Vectorworks, which the architects were using, and then we've got Revit and Tekla. All that was brought together, sort of at least when we go towards the federation, converting stuff into into IFC. What we also look at, which is part of our BIM execution plan, the BIM implementation plan within within Kia, is just to make sure that our subcontractors, or especially subcontractors, will be involved in the sort of in the BIM process. So we do send out questionnaires or capability assessments to ask them as to how what their capabilities are. And it's not to say that if they are low or if they didn't meet our expectations, we run away, but it's more of that supporting them to bring them to the table so that we can develop relationships and work together in on future jobs. On this particular job, we then had structural a steel fabricator, who we worked alongside with, and obviously, during the design stage, you've got the structural engineer's model, and then when we're going towards construction, or going before going to construction, we've got the fabricator putting their model, and then basically we then sort of at least make sure that what the fabricator gets, or what the fabricator produces, answers the design intent of the structural engineer. And in this particular incident, we have amalgamated or federated the structural and the fabricator's model, just because it's going to highlight as we go further about how we integrated what is the one of the areas, a cafe area, where we had glulam beams, structural steel, and an existing part of a building that we were sort of putting together in this. So. In terms, as I've mentioned about federating models or working in a BIM environment, is the key thing is try as much as we can to resolve problems before getting onto site. So the fewer errors that can be, the fewer errors that we sort of that we have, the better it is when we get to site. So you've got an optimized design. If you look carefully on the graphics that we've got here, is that the federated model, they've all been amalgamated in Vectorworks. We've got all the the models mentioned here, And one of the benefits that we reaped out of this is just being able to do almost a live clash detection, with the design team, and making sure that we save the views. And got an example of here where a clash was occurring between the ceiling panels and some of the MEP equipment. So within that system, you're creating less less errors, and then you're reducing waste. And what that also means is that you've got your site teams, they are not trying to sit there trying to to resolve what was not picked up during the design stage. Like I mentioned there, one area or one particular area that we would want to concentrate on, which we worked on, was the glue and beam integration into the structural model and also the existing building. So we've got an existing building here, and then the one that's slightly curved there, that's the new building. And we've got, if you look on here, we've got these glue lamp beams that are coming across. On the previous site, they were the ones that were in brown. So that's the same area, over there. So here you've got site-based teams. We've got office-based teams in different locations. That is the fabricator and the glue lamp, steel fabricator and the glue lamp beam supplier, as well as the structural engineer. So you've got a few of the consultants involved and working together to to get things working. So in terms of that collaboration, we had a few emails being sent through just to illustrate what people were, or what the different protagonists on the job were requiring, and asking for a bit more information. Please provide coordination point to hose in this bracket. It's things like that that helps our site teams work together. One of the things that we you worked with here was to get the site teams to to do the surveys and provide the coordinates to the structural engineer, then the structural engineer to integrate it into his as designed model, and then coordinate that with the glue and beam suppliers. So coordinates are obtained from site and then integrated into the design model, and then coordinate fixing detail with the off-site glue and beam supplier. So all this coordination, we're using Navisworks Manage. So having the whole idea of working together and making sure that the people on site are producing the the coordinates points that are required, and then they're then inputted into Autodesk point layout. We imported them into. You can import them into into Navisworks Manage. So basically, all the survey points that you saw on the previous slide, import them into Vectorworks, into Navisworks Manage, and you can even make them clearer, just to to see them through there. You can color code them, change the scale, and make sure that or isolate them, pretty much to as you will see in the explanation that Andy will give later on. So basically, you've got the the coordinate point that are picked up from site, and then you've got the structural engineer, picking up where the these glue and beams need to to go to, and then so they design their structure so that it aligns with the glue and beam design. So this whole process then gives us, the idea that we're gaining time. People don't have to, travel to sites, all the time. We're using, we're taking care, or we're taking advantage of, technology that without having to physically be on a site, we can be confident with the technology that, the coordinates that have been produced have been translated onto the design model, have been taken on by the fabricator, and, everything is working together. So, on the next slide that we see, you will, it's the process or the workflow of sort of getting the survey points onto onto the model using Autodesk Point Cloud. Do you want to go for it?
Just go back one. So we've got here is what's the point? In the import option within Navisworks and APL, and what I probably should have asked before we started, is there anybody in the room who's used APL, using APL? One. So APL, Autodesk Point Layout, is a little tool that sits inside of Navisworks, Revit, and AutoCAD, and it allows you to import discrete points. You can manually create those points in Revit, import a CSV file, Navisworks. Or if you're using Revit with APL, you can embed those points within the families. So rather than manually creating points every time you need to place one, place it in the right location in the family, and then when you import the family or the block into Revit, the APL point is already in there for you. The idea being that, in this case, it's a CSV file we've imported. You define your coordinate order, measurement units, and the coordinate system. So you can change the coordinate system at this point as well. Typically, we'd use the internal coordinate system of the model to keep everything federated and together. And these points can be placed by the designers, by the survey crews, by the engineers, by utility companies, anybody who's got objects within the model that they want to identify and verify on site. I've got to stress at this point they are individual discrete points. There's no intelligence to them as such, X, Y, Zs with a brief description. And we'll come on to it later in the presentation. Once the model's there, traditional workflow would be re-export the data as a CSV or an ASCII file out to your survey crews using toll stations, GPS, and they would go out, verify those points on site, download them again, CSV, ASCII file, DWG, DXF, all the usual file formats, USB drive in their pocket, in the car, drive home for the day, go to the office the next day. So there's a huge delay in getting the data from the site back to the office in some instances. APL, in conjunction with Revit, Navisworks, Glue, and BIM 360, pretty much makes that workflow real time, as quickly as you can get the data into the model in the office, sync it up to the cloud. Your crews in the field can get a message by text, phone, email on the app, download the new model, new points are there to be verified. Nobody's wasting time sitting around waiting for information to be delivered. So it's a number of ways to get points into APL, ASCII, CSV, or manually placing them.
So basically, sort of, after that whole, coordination process, sort of, this is the, the finished product, or at least some of the, some of the site photos that we can, actually see. And, one of the things which I mentioned earlier on about, sort of this sort of collaboration is that when the, when the glulam beams arrived on site, the installation was, was spot on. So all the hard work in terms of, using, Navisworks and using the different authoring tools that the consultants had used, and then, federating everything and sending out site data to the, to the glulam manufacturers. There was a real benefit in terms of, getting all that done. Basically, we got some recent site, photographs. I was on site a few days before, coming on here. So, it's all up and running, and it's a good, sort of a success story in terms of, sort of, working with from design, sort of having your teams to work together, and installation on, on site. So then we come to the one of the key elements, or some of the areas that we're trying to develop into, which is why we teamed up with TopCon and in particular is the idea of using laser scanning and on-site verification techniques. So basically, we are sort of trying to work with with technology and make sure that we don't get left behind, or we actually lead the the fray. I do want to go on to the next one.
Okay. So, Key has approached TopCon with the vision, the plan, the requirements that Thomas has outlaid, and asked if we had any hardware to help him, or to assist that, to do the job that he wanted. Quick answer was yes, and for no particular reason other than this was the equipment readily available at the time. We had the total station, the GT, and the AEC28 scanner. Quick show of hands again, if I can. Has anybody used total stations, laser scanners? No? Cool. So they both collect points in a nutshell. The total station captures, records individual discrete points every time you press the button. When you want a new point, you move it, discrete point. Laser scanner can collect anywhere up to 1 million points a second to produce scan data, ultimately your point cloud. It's a brief description of the scanner there. I got slightly ahead of myself. With the total station, we had two workflows. We could use our own software and introduce a complete traditional survey workflow to Keys. But why change that? Why introduce more software to a company that have already using Autodesk? We like the term keeping the data democratized. Free data open for all. Anybody involved in the project should have access to the data without worrying about data file formats. So initially, our software was only used to put out some ground control points for the project. And then we see the couple of screenshots or photos of the survey crew using it. Minimal setup time. We had the guys up and running within an hour or so of being on site. Installing the ground control points with say the total station. And then the reason we used the AEC28 laser scanner and not another one is it's designed purely for a survey workflow. So if you've heard of point clouds or used other scanners, the typical method these days of stitching all this data together is cloud to cloud. No control points, no reference. You just stick the scanner up, press go, collects the data, move it, put it down, press go. Then you stick the data together in the office. It's great, it's simple, it works. The only problem with doing it that way is you don't get any coordination in the point cloud. It's got no geo-referenced information. JLS has been designed to operate as a total station. So it's set up over a known point, backside it to a known point to get the orientation. Or we can do resection, so shoot to two known targets and calculate the positions back in the office. The big advantage of doing it this way, using the station and backside, again, keeping everything democratized, and rather than introducing our software into the step to add another learning step in there, the data goes straight into recap, already registered. So all you need to do in recap is have a look at it, make sure it's in the right coordinate system, tidy it up, and export it. Nice clean point cloud in the format, which is already in-house with Autodesk, and that'll go straight into Navisworks, Revit, Civil 3D, AutoCAD, any product that'll support point clouds. And then using Navisworks, we can take all the data from all the instruments, all the sensors that we've spoke about, and put it in one place in the federated model. So in this screenshot, and we can't really see it all, but we have the model from Revit, clearly visible. There are ground control points in there, which were obtained from the total station initially on site. We have points in there from APL, from the designers or the surveyors that want to locate discrete points or discrete elements. And then you can just about make out the black around the white building there, the railing. That's the point cloud brought in there as well. And with any of that information, you can use the Navisworks functionality to clash detect, run your time scale, time analysis, all the usual tools you have within Navisworks.
And basically, as Andy was touching on, what were the benefits that we we picked up from such workflows. So we kind of picking up validation of how we have on whether we have actually constructed in this instance the the steelwork. Has it been installed as as per the design? And so basically, if there was an error now, we could pick it up and make sure that we rectify it before it's too late, rather than wait until the project is finished. One of the other things that we benefited from here is we are used to do design versus design clash detection, but in this case we're looking at design versus as constructed or as built, looking at building tolerances. So at least if there's any deviation that's within what has been designed according to the specifications, that's okay. But the more if we start to deviate further, then we go to rectify the situation before it's too late. Again, it's time and cost savings that are made, if at all. In this instance, the as-built there were no clashes that were picked up as we did that. And we know that clients will start asking for for us to to verify our construction projects. So it's a good test case to start working with various consultants and using software that will help us to make sure that we stay on top of how we construct and how we get on with the work that we carry out on our site. The next section, we're going to deal with adopting technology on our construction sites using BIM 360 field, glue, and Autodesk point layout. So starting off with BIM 360 field. On this particular project, we are within our system, we talked to Autodesk to see if they would help us pilot introducing BIM 360 products onto our sites, and basically we managed to get that. So that's ongoing on this on this project. What I've shown here, obviously you wouldn't be able to to read through the actual content of it, but this is a shot of how we currently, or how our teams were working before we introduced technologies. So you've got a site diary, which in the BIM 360 field application is called the the daily updates. So basically we trying to then create cloud-based technologies to capture day-to-day site activities. What we then went on to do was to look at how that can be. So we translated that site diary into into the BIM 360 or BIM 360 field format. And what we can capture almost in an automated way or semi-automated way is to pick up all the consultants that we're using on site. We can subcontractors and all the hours that they are working, and so you've got an automated time calculation to see how your site labor is progressing on site. And what we also have is photographic evidence, which is a real benefit as we progress, because we can have got good records of what we have done, and if anything, if somebody came later on to try and intimate that some things were not done properly, or any comments that may have been made, we can always refer back to the site diaries, which we currently do, but in a different way, because you've got to use different system. You probably use handwritten notes and putting them into scanning them in, and then storing them onto a server. But in one go, you're having technology help you to, to amalgamate all that into one place. Checklist. So what we also do is to look at, quality management, and just to make sure that, as we install things on site, they're done according to procedures that have been produced by our teams. And basically, again, as in the previous case, using BIM 360 field with the site diary, this is the standard format that KIA uses in the traditional way of quality checking. And basically, we translated that into BIM 360 field checklists. And basically, our site guys can go onto our site and just quickly look through what has been carried out. Because there's all these are series of questions as to whether they've been done or they've not been done. So rather than looking at it as looking for problems, it's capturing evidence that we've actually done it. We've got photographic evidence of the fact that we've actually checked what's being done. So using BIM 360, it means you can go into the details of what you have onto that quality checklist. So you can pick up the details. You can fill in all the information that's required, including whereabouts that that space is in the building, and you can take photographs which you can put in as attachments. So basically, in the Glulam BIM workflow that we did, so people can actually just double check that the installation or the specification does has been they've done it according to the specification. And what also you can do is to when you've taken a site photo that relates to a particular quality check, you can actually rename it to whatever that means. So if somebody else came on board, they can actually very quickly pick up what that site photo is all about. So that's an enlarged image of this particular one. And what you can also do is then you can actually mark it up, and just if there was a particular place within within that photograph that you want to zoom in, that you want to make sure that people are aware of, you pretty much can highlight that place. Again, again moving from traditional ways of of working and going into adopting technology on sites. Issues which are which we here in the UK we know as snagging, is the snagging list. Again, I think the overall theme within this is we're not changing the overall process of how our site teams work, but we're introducing technology into it. So basically, take an existing way of how we capture our snagging lists or snags on sites. I mean, this existing tool that that we have, it does allow you to filter through and according to subcontractor, company name, or type of defects, and then you can summarize anything that you need. But I think it's a comparison, or just looking at whether if you automate it or if you adopt the BIM 360 field technology, how what savings can it come across, or what can you realize as benefits from it. So again, within BIM 360 field, you can pretty much have your all your snags just similar to the Excel spreadsheet that that we've got in the previous on the previous slide, and basically we are generating these these issues or things when within our teams as they walk around sites, as they see anything, they record it, they raise issues, put it onto the cloud, and basically it's instantly available to to all the teams that are working on the project. So myself as a design manager, if anything needs if KIA needs to do anything in terms of managing a design, we look at it. If the subcontractor needs to do anything, it's all on the cloud, so it's up for everyone to to interact with at the same time or in the same place. So again, looking at what are the in terms of looking at issues. So again, you've got the opportunity to actually integrate photographs into any issues that you have raised, so you can upload them as attachments. And it's not just the the attachments that you're able to put in. If you need a relevant specification or any other document that's there, you can actually be able to integrate into it. And what is also good is you've got a location. So basically, you can actually pinpoint. So you can draw and actually just see where in which particular room that issue has been raised against. And again, what you can see on there are the attachments, as in the site photos. So again, like I said earlier on, you can actually make sure that you customize the photograph to suit what it is that you are taking the photograph against, so that it's clearly referenced to to the problem or to the issue. And again, it's things like making sure that we've captured all the evidence, and people can actually review if they've got to come back and say, well, why wasn't the intermittent form, I mean, it's quite topical at the moment with the Grenfell Tower issue, where sort of a fire protection is not taken into consideration. So we've got evidence to say there was a problem, and basically when the subcontractor has rectified the problem, we can clear that that issue. So that's quite useful, and the guys on site are finding quite beneficial that we are adopting technology and making sure that we can keep up to the BIM requirements. So again, now coming back to using glue, pushing glue from site to the office.
So we have all this data in one model now. It's all in Navisworks from the central location. How do we then get that model and the required information from site, from the office, to the guys on site? Traditionally, it would have been USB sticks, ASCII files, and CSV, DWG files that I've mentioned. This project, we use Glue, Autodesk's cloud account. Glue in itself is a very powerful cloud service. For this project and this purpose, its primary aim was just data transfer. Upload the data to allow the guys in the field access to it easily and readily. So the model's there, and all the information. The points are there via Navisworks or Revit, Autodesk, AutoCAD, and APL. If you wanted to go a more traditional route and still use CSVs, there is a tick box. So you can take the points out of the model and use them more conventionally on site if you wish. To find the points, ping it up to the cloud. And then in the field, we're back to using the total station. And again, keeping the data democratized, keeping it open to everybody, rather than using in-house survey software, specific manufacturers' survey software. We use BIM 360 Field, which runs on the iPad. In the next half a dozen slides or so, just going to show you some of the functionality that the BIM 360 Field app has. The app itself, I should point out, is free. All you need is a Glue account. So the app only runs on the iPad at the moment, but I believe there are plans to change that and put it running on other platforms. So rather than seeing traditional survey tools where you've got numbers, and arguably you have to be an engineer or a surveyor to understand numbers and coordinate systems, they would say, Autodesk could come up with this great idea: don't display numbers, put the user in the model. It's designed for non-surveyors, non-engineers to be able to pick this up, connect it to a total station, and visually see where you are on site. So joiners, plumbers, electricians, anybody can use this. Even down to the level where it shows you where the total station is set up, or it needs to be set up. Flat battery. So for a non-surveyor or a non-engineer, the manager in the office can put a graphical representation of the instrument where it needs to be set up and highlight the point of orientation. Once the instrument's orientated, you can select a point from the bottom section of the screen, which are the points that were defined in APL, and tap. There's a button on there, I don't know if you can see it, and halfway down the screen there, it says turn. You press that, the instrument automatically turns to the location of that point, and then the top right-hand corner of the screen where you see the red numbers, it's your deviation. So it's comparing the coordinates of where that point is in the model, or where it should be, compared to where the total station thinks it is, to where it physically is on site. So in an ideal world, those red numbers will be green and 0. Practically on site, they're never going to be there. You're always going to get a few millimeters, hopefully at best, discrepancy. But it'll tell you which way to go. Do you need to go away from the instrument, left, right? And when you're within tolerance, the numbers will turn from red to green, and that's about 50 mil XYZ tolerance as it works on. And we simply hit the collect button just underneath the red numbers to record the point. It ticks it, and it automatically moves on to the next point. So that process is used for verification, setting out. There is a simple data collection tool in the app as well. So not only can you verify points that the office have sent you, if you see an issue on site, if there's a clash, if there's a plug socket where it shouldn't be, you can change the app from layout to collect, and you can record that position. You can highlight it, you can sketch on the model as a clash or an issue, and then you can sync that data sent back to the office. The guys in the office can pretty much say there's an issue on site in real time. When the data is collected, we've got some simple data entry field you can add some information to. It's a point number, row, type, description. Most of it is user definable. You can put your own forms in there. It gives you the coordinates. You can add some extra text. There's some filtering options in there. So if somebody in the office has gone bananas and sent you every single point in the model, as a joiner, somebody setting out piles, you're not going to need half of that information that's in there. So use the filtering options. It will only display the information that you need. You can filter by point number, description, row, type, any element that allows you to manually enter information, you can filter by. The iPad itself connects to the instrument via Wi-Fi or Bluetooth. The only requirement from the field guys is to have internet access when they initially download the model from Glue onto the iPad. Once the model's downloaded, it's stored locally. Don't need internet access anymore. So you can use your Wi-Fi to connect to the instrument, Bluetooth if you prefer. Once you're finished on site, disconnect from the instrument. If your iPad's got a SIM card in it, great, you don't need to worry about connecting to the Wi-Fi again. If you need the Wi-Fi, back to the office, connect the Wi-Fi, and it's a simple drag the screen down and release it, as you do with so many other apps. And it'll sync and update all that information back to the model. And the real beauty about it is it only updates in the cloud any new information. So it's not duplicating anything that's already there. And then we're back into Navisworks in the office. If we uploaded the data via the cloud, we'd connect to the Glue, download the model with the new information. Or again, if it was carried out more traditional way with a traditional survey kit, you've got a CSV, you've got an ASCII file. We can import that back into Navisworks. And again, it's a bit vague on the screen there, but what you see is a deviation report. So it's a delta XYZ value from where the points should be in the model, where the manager, designer in the office has said to be, against where they actually are in the field.
The next set of slides was, pretty much, sort of just to have another look at, some of the areas within within the project that we benefited from using Autodesk point layout. But we won't be, dwelling too much on them. But basically, it was trying to, just check all the, internal partitions as to whether they've been built, sort of to the design. So all those points are, sort of just validating whether, the partitions have been built to where they've been designed. So I'll just really pretty much skip through that. And our side guys again, pretty much getting used to carrying their iPads and sort of reaping the benefits of using the Autodesk products, but at the same time being able to integrate other other bits of software which the design team and all the other project stakeholders use on site. So I guess so the parting shot from what we've experienced on this project is if you can embrace technology, you might as well go for it. It's quite useful. If if site guys can just go on to a build in terms of quality management, go out there, look at whether sort of the temporary bracing has been installed in accordance to the method statement. Just literally just press on a button, yes, and if the bearings been do they comply with the specification, and just look at the different aspects on our quality checklist and just pretty much touch the iPad and get it all done. So all the stuff that we have got, or all the what we've been provided by the BIM 360 field in particular, we've sort of got all the is it gonna? So we've got all the the issues checklist, daily updates, which are the site diaries. That's what we've pretty much benefited from. So BIM implementation in terms of Kia, we've got a really strong position. We're in a very strong position to sort of to get BIM going within the group. I mean, obviously, you've got to get people to work in a different way to what they are accustomed to. But sort of the key factor is if you've got technology that's simple to use and sort of that answers your questions at every single time. What we have noticed, so in terms of trying to implement BIM is that if a piece of software or a piece of equipment doesn't sort of work in the way that the guys on site are used to, or doesn't actually say does what it says on the tin, they just give up very quickly. So we've been very careful in terms of training and making sure that people have got the right equipment and they've got the right training and the products are reliable, and sort of getting experts from both from Autodesk. We've got a consultant who has been working with us on the pilot, and so really people are the benefits that we get, time, financial, and we also have non-tangible benefits that we can get out of this. We've got about 7.5 minutes left to the slotted time. If anyone has got any questions that they would like to ask regarding the presentation.
Do you have any estimations of the time savings that you've generated through using this workflow?
Well, we are still in the middle of the of the pilot, and basically one of the one of the items that I've got on the iPad here is a clear. We've been talking to the to the site guys and just trying to find out how is this system working differently from what they normally do. So what we've begun to do is to collate the metrics of of this. For instance, one of the questions would be what's your normal time required to do a quality check on site, as opposed to what processes do you go through, so basically in terms of the last slide where I was saying you can just go and see if something has been done correctly, and then you can just press a button, and they were talking about the fact that they've got to go there, sort of either take a photograph, email it to themselves, or download it onto a server, and then get that information collated and then send out. So we've got some stats that are beginning to to come through. So we'll collect that and make sure that we can see what the tangible benefits are from implementing this this system. Any more? Well, thank you very much for sticking with us. Hopefully you picked one or two things from the presentation. Thank you.
Thank you.